If you're a space geek, then you need to know just how close we are to saving Earth from meteors. Ready for a cosmic reality check? In the next 8 minutes, we'll unravel the real science behind stopping a killer meteor. From Hollywood myths to NASA's bold plans, buckle up as we explore high-stakes missions. But here's what Hollywood gets wrong. Real asteroid defense isn't about sending oil drillers to space or detonating nuclear bombs at the last second. The truth is far more fascinating. NASA and space agencies worldwide have been developing actual asteroid deflection technologies. Asteroid-busting tech, take NASA's DART mission, the Double Asteroid Redirection Test. In 2022, this spacecraft successfully crashed into an asteroid, proving we can actually change an asteroid's path. But deflection is only half the battle. First, we need to find these cosmic threats. Currently, we've cataloged over 90% of near-Earth asteroids larger than 1 kilometer. That's the good news. The concerning news? Smaller asteroids, those 100 to 500 meters wide, could still devastate entire cities, and we've only found about 40% of them. And what would actually happen if a giant space rock came our way? 66 million years ago, a 10-kilometer asteroid ended the age of dinosaurs. The impact released energy equivalent to billions of nuclear bombs. Today, even a much smaller asteroid could be catastrophic. A 100-meter rock hitting a populated area would release energy equal to hundreds of nuclear weapons. The 1908 Tunguska event in Siberia flattened 2,000 square kilometers of forest. Imagine if that happened over New York or London. A larger impact wouldn't just destroy the impact zone, it could trigger global climate change, crop failures, and societal collapse. So what are the odds? NASA estimates a civilization-ending asteroid hits Earth roughly every 100 million years. But smaller city-killing asteroids? Those arrive every few thousand years, and we're overdue. Will we be heroes? NASA's Planetary Defense Coordination Office coordinates global efforts to track and potentially deflect dangerous asteroids. We have multiple deflection strategies, kinetic impactors like DART, gravity tractors that slowly pull asteroids off course, and even ion beam shepherds for precise orbital adjustments. Future missions could include nuclear pulse propulsion for rapid response, or swarms of small spacecraft working together. New space-based telescopes will dramatically improve our detection capabilities, giving us decades of warning instead of years. But our best defense isn't technology alone, it's international cooperation. Asteroid defense requires global coordination, or just hope for a lucky break. The answer? We're becoming heroes, but we're not there yet. With continued investment in detection and deflection technology, we could become the first species in Earth's history capable of preventing its own cosmic extinction. Let's find out. The future of our planet may depend on the choices we make today in space.